Shown in the diagram is a cylindrical container of radius r with a hemispherical base also of radius r. Given that the volume of the cylinder is 48 centimeters cubed and that the total height of the container is 8 centimeters, find an equation in r. Using a suitable iterative formula, find correct to 4 decimal places the value of r. Okay, so the important formula is that the volume for the cylinder is pi r squared h, and then for a whole sphere the volume is 4/3 pi r cubed, so therefore for a hemisphere we just need to divide this by 2. So knowing the formula will be quite useful in this problem. Now, so the volume of the cylinder is pi r squared h, so h goes from here to here, but we have to allow in fact that the 8 includes this radius here. Therefore, the height of the cylinder is going to be 8 minus r, and then we need to add the volume of the hemisphere, which is 4/3 pi r cubed divided by 2, and that then will be equal to 48. So there's my equation. I just need to maybe simplify it. So expanding the bracket, we're going to get 8 pi r squared minus pi r cubed, pi r squared times r, so minus the 2 and the 4 cancel, so we're going to get 2 pi r cubed over 3, and then minus 48 will be equal to 0. We can collect these two terms together, so we've got 8 pi r squared, so minus pi r cubed plus 2/3 pi r cubed is minus 1/3 pi r cubed minus 48 is equal to 0. Now, we should really try and get rid of this fraction. So multiplying everything through by 3, you're going to get 24 pi r squared minus pi r cubed. And now don't forget to multiply this as well. So that will give you minus 144 is equal to 0. Okay, so this is my equation, which I now need to solve. What I need to know is where the root is going to be. So I can use my calculator to help me do that. Okay, so I'm using a Casio here FXCG50, but any sort of calculator with a table function will do. So finding the root using the table menu, so just going to find roughly where it is before I use an iteration formula. Okay, so first thing on my menu is I need to go to the table function. I need to put this in. Now I can't put it in terms of r, so every time it's an r, I need it with an x. Okay, and then I need to set the table up properly. So I need to set the table starting from some value like minus 1 and go up to about 12, and then I will get some, once I've set it and met the step 1, I can see from here to here, that there is a change of sign. This is negative on this side and positive on this side. That means there's been a change of sign. This here is just the value of the derivative, so I'm just going to ignore that. So the root is somewhere between 1 and 2. So the root lies between x is equal to 1 and x is equal to 2, as there is a change in sign, like I've just explained. Right, so now I'm going to try to come up with some iterative formulas for this. So starting with this, what I'm going to try and do is find one from r using this and then one from r using that. So finding a suitable iteration formula, I'm going to say that pi r cubed is equal to 24 pi r squared minus 144. Then I'm going to divide by pi, so r cubed is going to be 24 pi r squared minus 144 over pi, and then I'm going to take the cube root of that and see if that works. We'll check in a minute if it does. And then I'm going to do one with the pi r 24, the r squared. So I'm going to start with 24 pi r squared is equal to pi r cubed plus 144. Then dividing by 24 pi, I'm going to get r squared is pi r cubed plus 144 over 24 pi. And then I'm going to get r is the square root of pi r cubed plus 144 over 24 pi. Now I use the recursion menu here in the calculator, and I put these values in. Now, with the Casio, for R, you have to put AN squared minus 144 over pi, and then for the second one, you will need to put BN cubed plus 144 over 24 pi. So this one here represents that one, and this one here, we hope you can see it, represents this one. I need to set this up properly, so using the set function, I'm going to start at 1 and go to 10 iterations, okay? And I'm going to put the start value being 1 for each one, because we found that the root was between 1 and 2. Now, there are a couple of things here called A string and B string, which you could set to 1 if you wanted to look at the cobweb graphs, which we're not going to do in this video. Right, when I exit that and then press table, I get this set of results. Now, I can see from this one here that the numbers are actually diverging. So this formula is not going to be any good, but I can see from this one here, they're actually going to converge onto 1.42 approximately. Okay, so I'm not going to use this one, I'm going to use this one. So carrying on using that formula, and then I'm just going to get the values from the calculator. Now, you can just do this with a normal Casio calculator as well. If you just set the answer to be 1 and then write this in, and every time there's an R, write in answer and keep pressing the equals, you'll get the following right. So R0, the first value is 1, which we've worked out. After the first iteration, it will be that, and then we'll carry on. Okay, and see when we get some sort. So it's sort of converging here. Okay, we want it to 4 decimal places, so we've got a 9 here. We'll just do one more just to check. So we've got 1.42. Yeah, we've both got 9 here. This is not going up by too much. So therefore, we can say that the radius is going to be 1.4249 centimeters, correct to 4 decimal places. Okay, so this has been a video to show you how to solve a practical problem using fixed point iteration. I hope you've understood, and I thank you very much for watching, and maybe you could consider subscribing to my channel. Also, in the notes of this video, I will put a link to my video site, which has absolutely thousands of videos from A-level right down to Key Stage 3. Thank you very much for watching.